When we're dividing polynomials, long division is cool and all, but there's one main problem with it. It's long. So here's an even faster way to do polynomial division, and it's called synthetic division. All right, here's our first example. We need to divide these two polynomials. We've got like a quadratic equation looking thing at the top, and then we've just got x minus 2 in the bottom. So synthetic division, which is the faster version of long division, only works when you have x plus something or x minus something at the bottom. So if you had like 2x minus 5, or if you had x squared plus 4x plus 3 or something at the bottom, then you can't do this. You'll have to use long division. And remember that fractions are the same thing as division. So if you had this and then a divided by sign and then x minus 2, then this would mean the same thing as a fraction. So here's what we're going to do. We're going to take this number right here that's next to x, and we're going to put it in a box. But we're going to use the opposite sign. So because this is minus 2, we're going to take positive 2 and put it in a box. If this was plus 2, then we would put minus 2 in the box. And now we're going to take the first number of each of these terms and lay them out here. So here we have 2 at the beginning, so we're going to put 2. Next we have, well, there's no number in front, right? But when there's not a number, it means 1. So this is going to be minus 1. Make sure you include the minus signs as well. So minus 1. And then here we have minus 6. Then we're going to go ahead and draw a line under here, leaving room for some numbers. And we're going to draw another line right here before our last number. And this is going to be where our remainder is. I know this seems more like a Bob Ross tutorial than a math tutorial right now, but trust me, the math is coming. So our first step here is to just bring this first number here down here. Easy. But then we have to do multiplication. So we're going to take this number and multiply it with the number in the box. 2 times 2 is 4. So we're going to put a 4 here in this empty space. And now we're going to add these numbers together. So minus 1 plus 4, that's the same thing as saying 4 minus 1. 4 minus 1 is 3. So that gives us 3. And that's going to give us our next number at the bottom. And then we repeat. So 3 times 2 is 6. And then negative 6 plus 6, well, that's the same thing as 6 minus 6, which is 0. These cancel out, right? So we figured out our answer, and it's going to be right here. But what does this even mean? Well, it's not quite our final answer yet until we interpret it into x's and stuff. So basically, this number right here in the box is our remainder. But because we have a 0 for the remainder, we don't actually have to do anything with this. So we're going to ignore it for this problem. The next problem I'll show you what to do when the remainder isn't 0. So we're going to take this number here. This number is going to be by itself. And every number to the left, we add an x. So this is going to be our x term. If we had a number here, this would be our x squared term, and then our x to the third term, and so on. So we're going to have 3 by itself, and we have 2 times x. Then you just put a plus sign in between them, or a minus sign if they're negative numbers. So our final answer is 2x plus 3. All right, here's another example, and this one is going to have a remainder. So it's going to be a little bit harder, but if you want to try it yourself, go ahead and pause the video and attempt it, and then unpause and see how you did. All right, so we're going to set it up exactly the same way. We're going to take this number right here, and we see that it's plus 2, so we're going to take the opposite sign, so minus 2, and put it in a little box. And then we're going to take the beginning numbers of each of these and lay them out. So we're going to have 2 for x to the 4th, and then we're not going to put minus 3. You may notice that we have x to the 4th, and then x to the 2. We're missing an x to the 3rd, right? So whenever you're missing an x term, in this case we're missing an x to the 3rd, we will put a 0 as a placeholder. So we're going to have 0 for x to the 3rd, and then we just continue on. So we have minus 3, and then 2, and then minus 5. And then we're going to draw a line underneath here, and another line here for our remainder. So we're going to bring down the 2, and we're going to multiply. 2 times 2 is 4, and then we have 1 minus sign, so the minus sign stays. Then our next step is to add these together. So 0 minus 4, well, the 0 is not doing anything, so it's just minus 4. And then we repeat. So we have 2 times 4, which is 8. And then we have minus sign, 2 minus signs, so they turn into a positive. So we're just going to have positive 8. Then we add these together. Minus 3 plus 8, that's the same thing as 8 minus 3, which is 5. Then we have 2 times 5, which is 10. And we have 1 minus sign, so the minus sign stays. Then we have 2 minus 10. We had $2 and then lost 10, so we're down 8. And then we have 2 times 8, which is 16. And two minus signs, two minuses make a positive, so positive 16. And then finally, we have minus 5 plus 16. That's the same thing as 16 minus 5, which is 11. So I know that was a lot, and if you need to, you can go ahead and slow down and look at each thing that I did, but it's basically repeating the same steps over again. So our final step is to interpret what we have at the bottom here, because this is just a mess of numbers right now. Well, remember that this number here is going to be by itself. And then every number after that to the left is adding another x. So this is going to be our x term. This is going to be our x squared term. This is going to be our x cubed term, or x to the third. And if you had more, it would be x to the fourth, x to the fifth, and so on. So we're going to have 2x to the third minus, because we have a minus sign here, 4x squared plus 5x, and then minus 8, and that one's by itself. So normally we're done here, right? But in this case, this number here is not 0. This is a remainder, and we're going to have to use this remainder at the end of our answer. So what we're going to do is we're going to attach it to the end. We're going to put plus 11. It would be minus if it was a negative number. So we're going to have plus 11, but then we have to divide it by what we were dividing by at the start. So that's x plus 2. So we're going to have 11 over x plus 2. So there you go. This is our final answer. And if you wanted to check your work, you could multiply it by x plus 2 and see if you get what's at the top here. So now you know how to do synthetic division. But remember, this only works if you have x plus something or x minus something at the bottom. But if you want to be able to divide any sorts of polynomials, then you can always use long division. So if you don't already know how to do long division, then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments, and I'll be sure to answer your question. Thanks for watching.